So we just talked about taking these degrees and rewriting them in terms of pi as a radian. So remember that 0 was 0 radians. Do you remember what 30 was? Pi over 6, good. 45 was pi over 4. 60 was pi over 3. 90, that was nice and easy, right? Pi over 2. So those are ones that we practiced a little bit. You're nice and quick with them. I don't remember us talking about 105 one, do you? I don't remember that one either. But we did do 240. Can anybody do that conversion in their head? 4 pi over 3. Remember, 240 is divisible by 60, and it goes in 4 times. So 4 pi over 3. Yeah, good. And then 360 is all the way around, which is 2 pi. Some of those we'd like to convert rather quickly. Some of them we need to maybe use the formula. So if you ever have to do this, 105 times pi divided by 180, that's what you can always go back to. And I'll have students that they'll kind of just remember it, just write it down on the test. I have other ones that they'll use the formula every time. Anybody want to guess what both 105 and 180 are both divisible by? They're both divisible by 5. If I divide it by 5, I get 21 pi over 36. You could check that with your calculator. And then 21 and 36 are both divisible by 3. Divide them both by 3, and I get 7 pi over 12. So we can understand that some of those are going to take a little bit longer than others, right? So the question is, what do we end up using this for? Well, this is going to lead us into what we call the unit circle. I call it the circle of life. Some people call it the circle of death. I guess it depends on how you look at it. And I'm just going to write down a few coordinates right now. But this spot is 0 degrees. This spot is 90 degrees, 180 degrees, and 270 degrees. And I'm going to write these 3 angles in here. I'm going to call this one 30, this one 45, and this one 60. Next to it, I'm going to go ahead and write the radian measurement. 0 was 0. 30, we said, was pi over 6. What did we say 45 was? Pi over 4. 60 was pi over 3. And 90 we said was pi over 2. Again, that all comes from 180, which is pi. And remember, 270 is 3 of the 90s, so it will be 3 pi over 2. Okay? And then all the way around is 360 degrees, also known as 2 pi. So eventually, you're going to complete the entire circle, but you're going to add something else to it. And what we're going to add to it we call is a terminal point. The terminal point is, if you look at the angle, it intersects this part of the x-axis with a radius of 1. And that will create a coordinate right there of, and I'm going to call it 1, 0. We're good with that? What's going to be the coordinate up top here? This coordinate right there. I'm going to call it 1, 1. Close. So I don't go 0 over any. I just go straight up. 0, 1. 0, 1 is that coordinate. How about this coordinate here? It's back 1 and it's up 0. Very good. And then the coordinate down here would be 0, negative 1. My 4 coordinates. What I want you to understand is all of these other angles, they also have a coordinate. That's what we want to find today and figure out. Okay? That's called the terminal points. That's what we need to figure out. Kind of a 2-day lesson. We'll figure it out. First, we need a review of geometry. Okay? Right now, turn and share with the person next to you. What are your feelings and your memories about geometry? Go. Okay. Anybody have some negative memories of geometry? Okay. I understand. Okay. And I ask you to, that's not everybody's experience. I was a true lover of geometry, loved it. By the way, that's the first mathematics. So geometry is what came first. And after that, trig, and after that, calculus. And then after that, 2,000 years later, algebra. So most of the time in society, in the world, we've never had algebra. I know that's kind of where people like things, but geometry and trig came long before the others, okay? We don't have to remember a ton of geometry, but we got to remember this one piece here. And if there's anything that I get from students during this time is that they usually say, I never realized it was quite that easy, okay? So we're going to take something that you maybe thought was challenging once upon a time, we're trying to make it easy right now, okay? And it has to do with 30, 60, 90 triangles and 45, 45, 90 triangles. So I'm going to write that down. I have 30, 60, 90 triangles. And I have 45, 90 triangles. Okay? And they have some special properties to them. In order for us to be able to do what we need to be able to do in trig, we have to be able to work with those two types of triangles. So watch what I'm going to do here. This 30, 60, 90 actually comes from a 60, 60, 60 triangle. Watch what I'm going to do. See how I build that second part onto it? Agree that this whole thing would be a 60, 60, 60? And if we wanted just a 30, 60, 90, we would just cut it in half to get that top side, right? So if it's a 60, 60, 60, if this side is 10, what's that side? That side is 10 as well. And what's that side? 10, right? So you can see that if we cut it in half, then if that side was 10, then what would this side here be? 5. So when you get a 30, 60, 90 triangle, one thing you know is true is that if the hypotenuse is 10, the smaller leg is always exactly half. Simple as that. How could we get the other side? You could use the Pythagorean theorem, or you could use a nice shortcut. I'm only going to do this once because I never use the Pythagorean theorem and never do the students. But I'll show it since you brought it up. Okay? You don't have to write this out, but just watch. Suppose that was x. I would have 5 squared plus x squared is equal to 10 squared. And you get 25 plus x squared is equal to 100. Subtract the 25, x squared is 75, and we take the square root of both sides. Hey, is there a perfect square you can take out of 75? What? 25 goes in how many times? 3. And you get x is equal to 5 roots of 3. It turns out that this side here is always that times the root of 3. Every single time. That's all there is to it. So watch. We'll show you how easy this could be. And I know that, when you're in geometry, you maybe didn't quite see this, but you're a little bit older. You've seen it a second time, so it makes a big difference, okay? You help me here. Suppose that this was 20. What would this be? 10. What's this? Done. Suppose that this was 8. What would this be? 4. This would be? Suppose that this was 2. What would this be? 4. This would be? Done. See that? That's good business, right? Like that's pretty easy. We're going to use that property as we get into it. So we've talked about the 30, 60, 90. Now let's move to the 45, 45, 90. What's true about a 45, 45, 90 is that it's an isosceles right triangle. What does isosceles mean? Two of the sides are the same. Sweet. So that means if I know one of the sides, suppose that this side was 8, what would this side be? 8. Anybody know how to get the hypotenuse? Anybody remember? Here I multiply by the root of 3. Here I multiply by the root of 2. Just 8 roots of 2. And I could do the Pythagorean theorem to show you how it comes out like that every single time, but it does. So the cool thing is that you have the root of 2. So if this was 6, then this would be 6, and this would be 6 roots of 2. Pretty simple, right? I'm going to change it just a little bit. Be sure to lean in because you're going to use this moving forward. Suppose I had this as 10 roots of 2, and then I want to find the side. What would the side be? 10 and 10. Okay, you guys are really smart. I'm going to change it. Suppose we didn't have that. Suppose we had something else. Suppose we had 5. To go from here to here, we multiply by the root of 2. So to go from here to here, we divide by the root of 2. So you get 5 divided by the root of 2. Are you allowed to leave the square root in the denominator? No. So you multiply the top and bottom by the square root of 2 or the square root of 2, and you get 5 roots of 2 over 2. So this is the side if that is the hypotenuse. We're going to have to be able to do that piece. Okay? See that little trick? And then finally, suppose we don't have a 30, 60, 90. Suppose we have a 60, 30, 90. Well, good news is it basically all stays the same. Suppose that this side here was 14. What would this side be? Hypotenuse, how does it compare to the shorter side? It is twice the 28. So then the longer side is going to be 14 times the root of 3. Done. Okay, same rule applies. Okay? All right, let's make use of it. So we're going to use that to start to find these coordinates right here along our unit circle. Okay, and we're going to start with this one right here, which is pi over 4. Okay, so I'm going to go ahead and I'm going to take pi over 4. What is that in degrees? 45. Okay, and so what I do is I draw a 45-degree angle. And I always look to see what angle is formed against the x-axis. In this case, it is 45 degrees. So I write that. And what I want to be able to determine is the location. I'm going to draw a triangle here. I'm going to make a right triangle. We like to use right triangles in trigonometry. I want to find the coordinate of that intersection. Okay? And just so we all understand, again, this coordinate here is 1, 0, and this coordinate here is 0, 1. Okay, so we know those two. I don't know that one yet. Okay, so the first thing you just decide is this a 30, 60, 90, or is it a 45, 45, 90? Which one is it? 45, 45, 90. It will always be the case that the hypotenuse is 1, because we say that the radius is 1. So you always put a 1 there. Because it's a 45, 45, 90, we know that those two sides are the same. I remember for 45, 45, 90, to get from here to here, I multiply by the root of 2. So to go from here to here, I divide. So we got 1 divided by the root of 2. Can I leave the root of 2 in the denominator? No. So multiply the top and bottom by the root of 2. And I get the root of 2 over 2. That's the length of the bottom, which is your x value. Root of 2 over 2. With a 45, 45, 90, what do you know about this side and this side? They are the same. So this side is also the root of 2 over 2. And by the way, although that may have taken a little bit of time now, this could go much quicker for you in a little while. Okay, you're going to notice a pattern that develops. So let's go back to this side. And let's label that pi over 4 as the root of 2 over 2 and root of 2 over 2. That's one that you know to be true. You're not going to work on your assignment today. We're going to get through these 3 examples, and then we'll introduce it again tomorrow. And tomorrow you have a lot of time in class to work. I have to be able to come around and make sure that every single person knows what they're doing. Otherwise, we're going to be in trouble. Okay, 4 pi over 3. I got to convert it to degrees. Anybody know what that is in degrees? Good, 240. You guys are doing a really good job. So as I draw 240 degrees, how far past of 180 do I go? To get to 240, how many degrees past 180 did you go? 60, okay? I always draw my triangle against the x-axis, always against the x-axis. So you said you went 60 past. So that means that this is a 60, 30, 90 triangle. This is a 60, 30, 90 triangle. What is always the length of the hypotenuse? 1. You always write 1 there. How does the short side compare to the hypotenuse? It's half. And what's half of 1? A half. What did we do to the short side to get the long side? We multiplied by? The root of 3. And if you multiply 1/2 times the root of 3, you get the square root of 3 over 2. So when we look for this coordinate right here, okay, it has an x value, which is how far you went horizontally, which would be a negative 1/2, because we went backwards. And then how far you went vertically. We went down the root of 3 over 2. Let's write that coordinate on the previous page. The first 2 you just did, those will be the hardest 2 that you do the whole time. After that, it gets easier every single one that you do. This one says negative 5 pi over 6. What is 5 pi over 6 in degrees? 150. So we're going negative 150 degrees. So negative 150 is going to bring me right back here. Okay. Draw my triangle against the x-axis. How many degrees before I get to negative 180? What's going to be that angle measure right there? 30. So do I have a 45, 45, 90 or a 30, 60, 90? Yeah, 30, 60, 90. Well, that's easy. What's always the length of the hypotenuse? 1. What's the shorter leg going to be? A half. What's the longer leg going to be? Square 3 over 2. Do those numbers look familiar? Yeah, you end up using the same ones over and over and over again. You don't have to come up with them all the time. And I'll show you the numbers that get used over and over again. But so this coordinate right here, notice it's a little bit different from the last one. The horizontal is this one right here, so it's negative root of 3 over 2. And then the vertical is negative 1/2. Let's put that on the previous page, and we'll do one more. So it looks like 210 degrees. We hadn't put that one down yet. That's the same as your negative 150. But we said that that was a measurement of, this is a 7 pi over 6. And we got a coordinate of negative root of 3 over 2 and negative 1/2. Okay. And our last one. Pi over 2 is how many degrees? 90. And so I draw negative 90 degrees. Every time I do this, people automatically start to draw a triangle. You don't need to draw a triangle here. We're just wondering, where does it cross this spot? And we know what that spot is. What is that spot? 0, negative 1, yeah. We've already written that down on our circle. It's already there. It's right at the bottom, 0, negative 1. We've already got that. And so as we're doing this process, I showed it to you guys, and you don't have to do any of your homework today because you're going to be working on it tomorrow. We're going to do a few examples, kind of get warmed up and practice. We're going to need to do that. But if you notice, we came up with the numbers 0 and 1. That's if you end up on the axes, right? Okay, so those were the axes. We also came up with the numbers 1/2 and root of 3 over 2. What kind of triangles gave us 1/2 or root of 3 over 2? Were those the 45-45 90s or the 30-60 90s? Yeah, those were the 30-60 90s. And then we came up with the root of 2 over 2, and that got paired with itself. And that was for your 45-45 90s. Those end up being the numbers that you use every single time. So you can end up making a little bit of prediction about how it's going to go, right? And you can end up doing it actually a little bit more quickly. So do not worry about starting your assignment. We're going to pick up right where we left off with that tomorrow. We're going to practice a little bit of class right at the beginning so you remember, and then you're going to go through and complete the work on your own. Okay? Good job today.